Hello, welcome again to another edition of Uncle Chemist online class. Today we are going to be talking about something a little bit different from our previous topic. And today our topic will be titled allotropy. So this topic is specifically prepared for all SS1 students all across the world. In other words, all year 10 and 11 students all across the world. Now let's get started. What is allotropy? Allotropy simply means the existence of an element in different forms. The existence of an element in different forms, but the same physical state. What am I saying? An element like carbon, sulfur, or even phosphorus can exist in different forms. Let's take, for instance, when you look at water, we have water existing in different forms. We have water existing as solid, which is ice block. We have water existing as liquid, which is the water we drink. And we have water existing as gases, and that is water vapor. Now let's take, for instance, we said allotropy can be defined as the existence of an element in different forms, but in the same physical state. I repeat, allotropy can be defined as the existence of an element in different forms, but with the same physical state. Why would water exist in different states? This is as a result of the arrangement of the molecules of water. Let's take, for instance, if water, which has hydrogen and oxygen, these molecules may be connected to one another by a bond called covalent bond. Now, with this bond that exists in water molecules, it can result to atoms arranging themselves in different patterns. Atoms arranging themselves in different patterns to give rise to a new state of that substance. Water in solid state, the molecules that bond the water molecules in solid state tend to be closer to each other. They tend to be closer to each other. Then water existing in the liquid state, the molecules or the atoms that connect them tend to be further away from each other. Then water as gaseous state, the molecules or atoms connected to the atoms in gaseous state of water tend to be further away from each other. But in other words, these atoms remains the same element, but their arrangement tends to change. This gives rise to different forms of that particular substance. Now, when you look at carbon, carbon is the 6th most abundant element in the world. Now, carbon can exist in different forms. Let's take, for instance, when you look at diamond, you look at graphite, you look at coke, and you look at what we call fullerene. These are substances that the constituent atoms that makes them is carbon, but they exist in different forms. Now that is what we call allotropy. Now in this case, we are going to be talking about carbon allotropes. Let's take, for instance, this is a carbon atom, for instance, and don't forget it has 4 valence electrons. 1, 2, 3, 4. Now look at the second atom of carbon. You can see it has 1, 2, 3, 4 valence electron. Now these atoms may be connected to each other in this manner. Now look at carbon, but look at how they are arranged. So we are going to have the carbon that looks a little bit like a linear shape substance. What if this carbon decides to arrange itself this way? Would you say this is a linear shape carbon atoms? Of course no. Now this will give rise to a substance that is totally different from the previous one we did that was linear shape. Now this is what brings about allotropes of carbon, or the allotropy of carbon, because they are atoms of the same element carbon existing in different forms. This is as a result of their arrangements. The atoms are arranged in different configuration, giving rise to different forms of an atom. Now, this is just an example. Look at what I said again. This is the first shape now. This is the first carbon, and this is the second carbon. And look at the shape we're having. What if this carbon is now arranged in this way? Okay, let's do it this way. Now we have a straight carbon. Now, what am I trying to make you understand? It means this carbon can arrange themselves in different forms, in different arrangements, to give rise to different shape or forms of this same carbon element. And that is what we call allotropy. Two main allotropes of carbon, and they are: number one, the crystalline allotropes of carbon. Number two, the amorphous allotropes of carbon. These are the two major allotropes of carbon that we have. Now, for the crystalline allotropes of carbon, that's where we have our diamond. That's where we have our diamond and graphite. Diamond, and we have our what? Graphite. And we have one we call the fullerene. Fullerene. These substances are made up of carbon. Diamond, graphite, and fullerene. They are all made up of carbon atoms, but they are of different forms, and they are all grouped under the crystalline allotropes of carbon.